Previously, we checked solutions to a system of linear equations with two variables. Now we're going to start working on a system of linear equations with three variables, and in this one we're just checking solutions. So just as we did before, now instead of two equations we have three equations, so this is the introduction to your z variable, which makes it three-dimensional rather than two. And to determine if an ordered triple is a solution to the system of three equations, we do exactly the same thing we did before, which means I'm going to take each of my now three equations. I'm going to replace x with the x value. I'm going to replace y with the y value. I'm going to replace z with the z value, and I'm going to see if it equals what the solution says it should equal. So 2 times 0 is 0. 2 times negative 2 is negative 4. And then, of course, plus 5. Does that equal 1? Negative 4 plus 5 is 1. So we know that this ordered triple is a solution to my first equation. For my second equation, again, I'm replacing each of those values, x, y, and z. Notice that when I'm plugging them in, I have a tendency to plug them in parentheses because it helps me to make sure the signs stay the way they should. 3 times 0 is 0, plus negative 2, minus positive 5. I'm saying, does that equal negative 7? Negative 2 minus 5 is negative 7, and that equals negative 7. So far, so good. I know both of these equations go through the point 0, negative 2, 5. If it now works for my last equation, then I will say yes. So x is 0, y is negative 2, z is 5. I'm saying, does that equal 13? Negative 4 times negative 2 is 8. 8 plus 5 is 13. And therefore, because it worked in all three equations, I will say yes, that this is a solution to the system of three equations. One of those for you to try on your own, so give it a shot, then press play to check your work. For the first, again, I'm replacing x with negative 2. I'm replacing y with negative 6. Be careful here, this is a minus and a negative. I'm replacing z with 3. And I'm saying, does that equal negative 7? 5 times negative 2 is negative 10. Minus negative 6 gives me actually plus 6. Plus 3 times 3 would be plus 9. That gives me negative 10 plus 6, which is negative 4. Negative 4 plus 9 is 5. 5 does not equal negative 7. So I don't have to check any of the rest of these. I can just say no. It's not a solution. Once I find a no, then the whole system is a no.